DevOps and CI-CD Part 8. This episode has 13 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Ansible Multi-Cloud. You delivered Ansible IAC across GCP, AWS, and Azure. What did you handle differently for authentication and modules across the three clouds? Here's a strong way to approach it. Each cloud needed its own authentication mechanism. GCP via a service account JSON key or workload identity, AWS via IAM role or access keys, Azure via a service principal, configured through separate collections, Google Cloud, Amazon AWS, Azure as collection, with cloud-specific module naming and required parameters, abstracted common patterns, tagging, naming conventions, network setup into shared roles where possible, but kept cloud-specific modules and variable files separate since resource models and required fields differ significantly between providers. Nice. Let's continue. Question 2. Ansible with Kubernetes. When would you still use Ansible in a Kubernetes-centric platform? For example, bootstrapping nodes or managing non-containerized infrastructure? Here's a strong way to approach it. Ansible remains useful for bootstrapping the underlying VMs before a cluster exists, OS hardening, kubelet or container runtime install, joining nodes, managing infrastructure that is not containerized, bastion hosts, on-prem servers, network appliances, and one-off operational tasks like credential rotation or OS patching across a fleet. Once workloads themselves are containerized, Kubernetes native tools, Helm, Customize, operators take over application lifecycle management, with Ansible handling the layer below the cluster. Great. Moving on. Question 3. Ansible change management. How would you gate risky Ansible changes, like a fleet-wide restart, behind approvals while keeping routine changes fast? Here's a strong way to approach it. Classify playbooks by blast radius, routine, well-tested changes, config drift fixes, minor updates, run automatically via CI or CD on merge, while high-risk changes, fleet-wide restarts, OS upgrades, security group changes, require a manual approval gate in the pipeline or an AWX workflow approval node before execution. Always run, check, diff first so approvers see exactly what will change, and require the change to go through a small rolling batch, serial, even after approval so a bad change is caught on a subset of hosts before it reaches the whole fleet. Alright, next question. Question 4. Ansible architecture. Explain the components of Ansible architecture, including the control node, managed nodes, and how they communicate. Here's a strong way to approach it. The control node is the machine where Ansible is installed and from which playbooks are run. Managed nodes are the target servers being configured, which need no agent installed. The control node communicates with managed nodes over SSH, or WinRM for Windows, using the inventory to know which hosts to target, and pushes small Python modules to each managed node that execute the requested task and report results back, after which the module is cleaned up. There's no persistent agent or daemon left running on the managed side. Let's keep going. Question 5. Ansible push versus pull. What is the difference between a push-based and a pull-based configuration management model, and where does Ansible fit? Here's a strong way to approach it. In a push-based model, a central control node initiates connections and pushes configuration changes out to target hosts on demand, giving you direct, on-demand control over when changes happen. In a pull-based model, an agent on each managed host periodically checks in with a central server and pulls down and applies its own configuration on a schedule, which scales well for very large fleets but gives less precise control over exact timing. Ansible is push-based by design, connecting over SSH and executing immediately, which is why it needs no persistent agent, unlike pull-based tools like Puppet or Chef in their typical configuration. On to the next one. Question 6. Ansible inventory basics. What is an Ansible inventory file, and what does it typically contain? Here's a strong way to approach it. An inventory file lists the managed hosts Ansible can target, typically organized into groups, like web servers, or databases so playbooks can address a whole group at once, and can include per host or per group variables, connection details, environment-specific settings directly in the file. Inventories can be static, a plain ini or YAML file, or dynamic, generated on the fly from a cloud provider's API, letting Ansible target hosts based on live infrastructure state rather than a manually maintained list. Good. Here's another one. Question 7. Ansible Playbooks Basics. What are Ansible playbooks, and what does their basic structure look like? Here's a strong way to approach it. A playbook is a YAML file describing the desired state of one or more hosts as an ordered list of plays, where each play targets a group of hosts from the inventory and runs a list of tasks against them. A basic playbook has a hosts field naming the target group, an optional become field for privilege escalation, and a tasks list where each task names an Ansible module, like apt, copy, or service, along with the parameters describing what that module should do. Nice. Let's continue. Question 8. Ansible roles basics. What are roles in Ansible, and why would you use them instead of one large playbook? Here's a strong way to approach it. A role is a standardized, reusable directory structure that packages related tasks, variables, templates, handlers, and files for a specific piece of functionality, like install and configure ginks, which can be included in any playbook rather than copy-pasted. Roles matter because they keep large automation projects organized and reusable. Instead of one massive playbook mixing unrelated concerns, you compose focused, independently testable roles, which is especially valuable once multiple teams or many playbooks need the same underlying configuration logic. Great. Moving on. Question 9. Ansible modules basics. What are Ansible modules, and how do they differ from running a raw shell command? Here's a strong way to approach it. Modules are the actual units of work Ansible executes, small, purpose-built programs, like apt, file, copy, service, that Ansible pushes to the managed node, run, and then removes. Unlike a raw shell or command task, most built-in modules are idempotent by design. They check the current state of the system first and only make a change if the actual state differs from the desired state. So rerunning a playbook full of modules is safe, while a raw shell command has no such built-in safety and will simply re-execute every time regardless of current state. Alright, next question. Question 10. Ansible connectivity. How does Ansible connect to and execute commands on remote machines? Here's a strong way to approach it. Ansible connects to Linux or Unix managed nodes over SSH using either password or key-based authentication, and to Windows nodes over WinRM. Once connected, it copies the relevant Python module code to a temporary location on the remote host, executes it there, captures the JSON formatted result, and then removes the temporary files. All of this happens per task, per host, which is why no persistent agent process needs to be running on managed nodes. Let's keep going. Question 11. YAML basics. What is YAML, and why is it used as the configuration language for Ansible? Here's a strong way to approach it. YAML ain't markup language, is a human-readable data serialization format that uses indentation and simple syntax to represent structured data, lists, dictionaries, scalars, without the verbosity of XML or the strict bracket and comma syntax of JSON. Ansible uses YAML for playbooks because its clean, readable structure makes automation logic easy for humans to write and review, while still being straightforward for Ansible to parse into the structured task and variable data it needs to execute. On to the next one. Question 12. Scenario. Partial playbook failure. An Ansible playbook fails on host 40 of 200 mid-rollout, leaving the fleet in mixed state. How do you recover safely? Here's a strong way to approach it. First, check what state hosts 139 were left in versus 4200 by reviewing the task that failed and whether it was transactional, fully applied or not, or could have partially applied on host 40 itself. Use the auto-generated .retry file or a targeted limit at failed hosts retry run to retry only the affected and remaining hosts once the root cause, a bad package version, unreachable dependency, etc. is fixed, rather than rerunning against all 200 and risking side effects on the hosts that already succeeded. Add a health check task and smaller serial batches so a future failure is caught after 5 hosts instead of 40. Good. Here's another one. Question 13. Scenario. Vaulted secret rotation. You need to rotate a secret stored in Ansible Vault across all environments without causing a midday outage. How do you plan it? Here's a strong way to approach it. Add the new secret value alongside the old one first. Many systems support dual active credentials briefly, so services can pick up the new secret without a hard cutover. Update the Vault encrypted variable and roll it out via a rolling serial batch during a low traffic window, and verify each batch's health before proceeding. Only revoke the old secret once every environment confirms it's using the new one, and keep the old value available for a short rollback window in case a missed host or cached credential surfaces after rollout. Nice. Let's continue. That wraps up this episode. Nice work practicing, and see you in the next one.